Well, good morning. At long last, I'm doing the field test portion of my stray voltage testing. I've come out to a farm today. It's the middle of winter, so the milk plant's not in use, but I'll still be able to run water through it to do the testing. There are some cows going through to get air tags and to be drenched at the moment, but they won't worry us. We'll be working with the milk pump controller. I'm not doing the tests with one of my own brand milk pump controllers. It's actually a De milk pump controller, and I'm just doing this just to mix it up a little bit and to demonstrate that the principles are the same no matter what brand of controller is used. After I've done these tests, I'll be setting up my own controller in this plant and repeating the tests on that. So I suspect I'm probably going to have to just set the camera up and do the tests and then put the narration in afterwards. So here we go. My apologies, but it was just too noisy in the shed that day to use the audio that I recorded, so I'm doing a voiceover. Here's the De milk pump controller that we're going to use for the test. I've got my scope probe extension wires hooked up in exactly the way that's specified in the New Zealand standard literature. They're across the screen of the motor cable. I've got my scope set up on a table. As you recall from previous episodes, I have a switch in the scope power supply, which means I can isolate the earth, which duplicates what the stray voltage testers do in the field when they cut the earth pin off the plug. I'm not going to turn that switch off today. It's going to stay on and the scope is going to stay earthed. As you may recall from episode 4, if I turn that switch off, over 100 volts AC gets pumped into the shed metalwork, and there are cows in the yard next door attached to the same metalwork that's in the shed, so that switch will stay on. Okay, we're ready. Let's go. And here I'm just duplicating the test that we did in episode 4. Now what I'm actually showing is that with that switch turned on and the scope earthed, I'm getting a few millivolts out of the scope leads. Please note that I've got the actual clips disconnected at the moment, so that voltage isn't going into the metalwork of the shed. Now as an experiment, I'm turning that switch off and taking the earth off the scope, and we've got 120.567 volts AC coming out of the scope lead. As I keep repeating, I will not be turning that switch off during the test today. There are cows right next door, and the metalwork of the shed continues to the area where the cows are. So the switch is back on, and once again we've dropped down to millivolts. I apologise if you can't see the scale properly. You might just have to take my word for that one. So, yep, okay, let's continue with our test, and I'll see how the audio is on the later tracks. I might be able to stop doing the voiceover. Cheers. My apologies, the audio is still not quite clean enough for me to use, so I'm continuing with the voiceover. I've got the De controller powered up but not running, and I've got my scope extension leads connected across the motor cable screen, so one end at the drive end, the other end at the motor end. And there's that firing pulse that we were looking at in, I think, episode 5, firing pulse from the switch mode power supply inside the drive. It's a bit differently shaped to my one, but different manufacturers have a different design of switch mode power supply, which creates a differently shaped pulse. So it is the same power supply, it is the same pulse and coming from the same source. Now what I've done is I've cut a length of just normal wire, the same length as the motor cable. In the next scene I'm going to disconnect the clips from the screen of the motor cable and connect that wire in between them instead. That way they have no physical connection to the drive or the screen of the motor cable, and we'll see what result we get. Stay tuned.
So now I've got this piece of wire sort of running vaguely in the same direction as the motor cable. I don't have it connected to the probe's connected to anything. All they're connected across is that piece of wire. And there's our display. Okay, I'll continue and do some. So I've connected the two clips across the motor cable again. I just need to quickly try taking the earth off the scope just to see. Oh, we've got a bigger signal, there we go. Just to see what the result is. I'll only do it quickly, just on and off. Yeah, okay, it doesn't make any difference to the reading. So that raises the question, why cut the pin why cut the earth pin off the plug if it doesn't make any difference to the reading? Okay, so now I'm going to put some water through the plant and we'll have a look at what happens when we run the controller. Okay, now I've got the system full of water.
Okay, we're back on voiceover again because the cows are misbehaving. I've got the system full of water now and I can actually run the pump. I've got the scope probe extension leads connected across the screen of the motor cable as per the NZ standards test. I'm going to dial the scale on the voltage, the y-axis right up to maximum. And I'm also going to dial the time base right up to maximum. I do this because it makes it much easier to see what the peak voltage levels are. Okay, so the pump's now running with water in it. $30 volts is what I got there. You probably heard the original audio coming through. Absolutely ridiculous, cannot happen, is not physically possible. But the scope is showing 30 volts from one end of the motor cable screen to the other end of the motor cable screen. Okay, in the next, yep, okay, I'm just going to prove now, now that it's come to a stop, that we've still got our original firing pulses there. In the next segment, I'll be disconnecting the clips from the motor cable screen and connecting our piece of wire in their place.
Okay, here we are. Got our piece of wire again that's substituting for the motor cable screen. Let's give it a run and see what happens. Oh, I better dial the time base up again. There we go. Ah, sorry, I forgot to dial the time base. There we are, nice slow time base so we can get a good idea of what's happening. Okay. There we go again. And a little bit differently shaped waveform, but still pretty similar. Whatever this is a test of, it's not a test of the voltage that's present across the screen of the motor cable. It's radiated emissions picked up as easily by a wire as by the screen of the motor cable. Thanks. Bye. Okay, what we're doing now is I've set up one of my controllers, and actually this is one that I had returned because it failed its stray voltage test out in the field. I've set it up here in the same dairy shed. The D-level controller's just up there, and I've set it up just recirculating into a barrel with a 1.5 kilowatt centrifugal pump. I'm using the same float that was installed out in the field when the unit failed the test. I asked for the motor cable as well, but that didn't get returned with the unit, so I'm using a new bit of motor cable. Okay, so because none of this equipment is touching the metalwork in the shed, I'm going to turn the earth connection off on the oscilloscope because I'm quite confident that the voltage the oscilloscope's putting out isn't going to get into the shed pipework. So I'll go ahead and fill my barrel with water and be back soon. Okay, so here we are and we're all set up. Got the drive powered up but not running. The pump's all connected. It's a 1.5 kilowatt centrifugal, and it's just recirculating into this barrel. So I've connected up the test clips as per the New Zealand standard specification, and I've got, with the drive not running, I've got that same firing pulse on the screen. It's jumping around a bit. To be honest, I don't know why that is. But anyway, we've still got the pulse there, and the amplitude is roughly about 60 millivolts, so it's quite low. We obviously haven't got a very efficient aerial on it. Now this scope does have a frequency display down here. It can't work on pulses. Whatever you see on that frequency display there, if you're not recording a solid continuous frequency, that is just absolute rubbish. You need to ignore it. Okay, so now I'm going to start the pump. And I'm going to run it up to full speed. I've already set the gate valve that I've got on the pump discharge so that the pump will run at full load when it's at full speed. Now I'm going to turn the time base up so that we can get an idea of the amplitude of this waveform. And there we are, and we're on 2 volts per division, so we're looking at probably about 3.5, maybe let's call it 4 volts, shall we? Okay, so that's all good. I'll let the pump stop. Just the pump out timer is running at the moment, so it'll take a wee while. I'm just going to stop the video. I'll restart it again once I've put my bit of wire between the test clips. Okay, so here we are, we're back again. We've just got our bit of wire that's looped vaguely in the same general direction that that the motor cable runs in. It's not connected to anything. The clips are just connected to the end of the wire and to nothing else. It's not going to be as efficient an aerial as the motor cable, but there we've got our firing pulse, and it actually seems to be picking that up better. Let me just get a reading. Oh. No, it's jumping around again. Tell you what I'll do is crank the time base up. And then crank the voltage up and we'll get a level. So we're looking at 2040 50 millivolts. 50 millivolts out of that bit of wire. Now let's start the drive. Run it up to full speed, And let's adjust our time base, our voltage, till we can get a reading. And the reading is 1, 2, 3, 4, 5, 6, 3 volts. 3 volts, there you go. That would fail any test, any maximum levels that are in the New Zealand standard, and yet this is it. There is nothing else except this bit of wire. So these are radiated emissions. These are not conducted emissions. Yeah, I'm sorry, but that's the beginning and end of it. It's an aerial. It's purely and simply an aerial. It's picking up magnetic interference and transforming it back into electrical signals. Okay, thanks. Bye. Hi, Maurice Coates here. I completed episode 6 in the stray voltage testing series, and when I viewed it I realised that I'd completely forgotten to explain what exactly I was specifically testing for in the field test. So just let me explain quickly. The problem is I find so many things that aren't right with this test that I tend to jump around between them, because quite honestly any single one of them would render the test invalid. But the main thing I'm focusing on is the difference between conducted emissions and radiated emissions. Now the test is supposed to pick up conducted emissions. I've checked this. I've checked it with the New Zealand Standards publication. I've checked it with Peter Jews personally, and the test is specifically meant to pick up conducted emissions. What I believe I've proved conclusively in the workshop here is that it doesn't. It picks up radiated emissions, and that was my primary reason for doing the field tests, was just to positively prove that in a real dairy shed under real conditions, and using 2 different brands of controller, mine and a de Laval controller. So this is the nexus of the test. That this is what it was all about. Here's our oscilloscope, and the test rig that's advised by Standards New Zealand is to put extension wires from the probe and its clip, and the standard says that these extension wires, which in the picture they've got in the Standards New Zealand publication, have huge big battery clip type things on the end of them. The instruction is to clip them between various bits of metalwork in the shed and make sure that you don't get voltage beyond certain limits on the scope. So the test that particularly concerns me is the one that's done between the variable speed controller and the motor, and it's done across the screen of the motor cable. Now the motor cable will have a braided screen around the conductors inside, and this braided screen is the reason it's constructed as it is to have very low resistance, very low impedance and extremely low capacitance, and in other words, to act like a dead short. Now, the tests are picking up substantial amounts of voltage across that, and it's my contention that all this voltage is being picked up by these leads, and it's actually radiated magnetic emission which is converted back into voltage by these leads acting as an antenna. So out in the field, what I've done is every time I've done a test, I've done it twice. I've done it once with these clips connected across the screen of the motor cable. Then I've taken the clips from that screen and I've cut a length of wire, just plain ordinary wire that you could go to your local electrical wholesaler or to an automotive shop or anywhere to buy. Just plain copper wire, and I've connected it straight between those two clips. And the object of that is, with that plain bit of wire connected between the clips, there cannot be any voltage between them. It's just an impossibility. It cannot happen. So if anything shows up on the scope, that means that the only way it can be being picked up is as radiated interference, which is transformed by these extension leads on the scope probe back into a voltage signal. And so what I'm looking for when I do the two tests in the shed, the first one across here and the second one with a bit of wire between the probes, is to see if they're the same or very similar. And I don't want to spoil the surprise, but in every test that I do out in the plant, that is the case. It actually makes an absolutely negligible difference whether you're connecting across this screen or whether you've just got a straight bit of wire going from clip to clip. I already knew that this would happen because of the tests that I did here, but I needed to confirm it in an actual dairy plant, and that's what I've done. So sorry to have to give you the big long explanation, but I realised when I viewed the video that I did not make this point effectively, and so I felt I had to insert this segment. Okay, thanks. There'll be a final video, and it will just be a summing up of everything I've learnt, and the facts and the data, basically. And that there'll be a written report as well, and I'll give instructions in the final video about how you can get hold of the written report if you want one. Thanks very much. Bye.